All right, moving on to 5.4. Now we're looking at solving a proportion. So these are cases where you've got an equation where you might have something missing that we're trying to solve for. So we already know an equation is a statement that two expressions are equal. So for example, here we have 15 times A equals 30. A is what we would call a variable. This is our unknown quantity. We could write an X, we could write a little smiley face. It's just a symbol to let us know that we don't know what this thing is yet. So unknown quantity. And so a little bit of terminology for you. First of all, variable should be on that list. Let's put it here. So variable is our unknown. Coefficient is going to be the number in front of that variable. So in this case, with 15a, our coefficient here would be 15. So when we go to solve proportions where we have an unknown value, first what we're going to do is we're going to write ourselves an equation. So based on what we know, we're going to use the proportion rule and we're going to write that equation. Then we're going to divide both terms by the coefficient, and then we're going to check our answer. So for example, here they've given us this equation. So we don't know what X is. So we have 8 over some unknown X equals 6 over 9. So we're going to do the cross product here and say, well, that means that 6 times this X equals 8 times 9, which is what they've written here. Okay, so another way to write 6 times X is just 6X. So it means we have 6 X's. 6 X's equals 72. If we want to know what just one X equals, we need to divide both sides by the coefficient. So here we divide both sides by 6. And that's going to let us know what just X on its own equals. Because 6X divided by 6, we can cross out those 6's, and we're left with just X. So X equals 72 divided by 6, which is 12. If you wanted to check your work then, what we're saying is that if we put 12 in for X, that would be a true statement. That equation makes sense. So we could check it by doing that. We're going to put a 12 in where we had the X in our original equation. And then if you do the cross product method here, you should find that 8 times 9 equals 6 times 12. And it does, so we know we're correct. Okay, here's another kind of tricky example. So here we've got 1/4 over 3 equals 4 over X. So I'm going to do the cross product method on this. Draw my X. And so what I get is right here, 1/4 X equals 12. Well, here I want to get rid of that 1 over 4. And you know from which chapter was it? Chapter 3, I think, where that if we multiply something by its reciprocal, it's just going to become 1. So I can multiply this by 4 over 1 or 4. I'm allowed to do that as long as I do it to the other side of the equation. I'm allowed to do whatever I want to the equation as long as I do it to both sides. So if I multiply by 4 over 1, those 4's we can reduce down to 1. And so we end up with 1 or just plain X. So now we have just plain X equals 12 times 4 over 1. Remember, 12 is really 12 over 1. And so we get an answer of 48. And then just like we checked in the last example, we can check here by doing the cross product method. So if we do 1/4 times 48, do we get the same thing as if we do 3 times 4? And here, yes, we end up with 12 equals 12. So let's do one of these together, and then I'll break for you to do some on your own. So first thing we're going to do here, so we have 4/5 equals something over 25. So I'm going to do the cross product. And so that is saying 5 times X, or 5X, equals 4 times 25. Okay, that's what 5X's equals. And I could take it a step further. Let's do that multiplication. 4 times 25 gives us 100. So I know 5X's is 100, but I want to know what just a single X equals. So here, I'm going to divide by the coefficient. I'm going to divide by that 5 because I know if I do that, my 5s will cancel out and I'll be left with just an x on the left. I'm allowed to divide by 5 on the left as long as I also do it to the right. So whatever you do on the left, you want to make sure you do to the right. So here we get x equals 100 over 5, which is 20. And if I wanted to check my work, let's check it down below. So if that's true, I'm saying 4 over 5 equals 20 over 25. Well, if I check that with the cross product method, I'm saying 4 times 25 equals 5 times 20, which means 100 equals 100. So that's true. Another way you might think to check this one is we could also say these are equivalent fractions, right? So to get from 4 to 20, we had to multiply by 5. To get from 5 to 25, we also multiplied by 5. So we know these are equivalent fractions. All right, so go ahead and try B and C on your own, and then come on back. All right, so hopefully you had a chance to try these next two. Let's do them together. So I'm going to do the cross product here. And so another way to write this is 5 times x, or 5x, equals 9 times 12. So 5x equals, what's 9 times 12? So it's 108. So now I know what 5 x's are. I want to know what just one x is. So I'm going to divide by my coefficient. I'm going to divide by that 5. And that's going to give me, whoops, x equals 108 divided by 5. And 108 divided by 5 gives me 21.6. So your answer here is a decimal. Okay, and let's do another. So using the cross product method here, I'm saying that 3 times 25 equals 4 times x, or 4x. 3 times 25, that's 75. So 75 equals 4x. This time our x is on the right, but that's okay. It doesn't matter. In fact, if you like it on the left, you could flip it right now. You can always flip across an equation like that. So we could say 4x equals 75, but I'm going to leave it the way it is. So I'm going to divide both sides by 4 here so that my 4s will cancel out on the right and I'll be left with just one plain x equals. So x here is 75 over 4. And if I do that on my calculator, I get 18.75. Okay, next one is a bit trickier because now we have a fraction, but we do it in the same way. So we're going to take our cross product here. So we're going to get 1/2 times d equals 3 times 5. And sometimes I like to use these dots just because then if we have x's, it doesn't get confused with multiplication symbols. Okay, now I know, well, here I can go 1/2 d equals 3 times 5. If I can do that multiplication, I'll get 15. Now I know what half a d is, but I want to know what a full d is. So this is a case now we've got a fraction out in front of that variable. So we want to multiply by its reciprocal. So I'm going to multiply by 2 over 1, or 2. Remember, this 15 is really 15 over 1. So then on the left-hand side, these are going to become 1s. So I'm going to be left with 1d, or just a plain d. So d equals 15 times 2, which is 30. Okay, now we've got a decimal. And we can do the cross product again on this. So we're going to have 0.4 times 30 equals 2 times x, or 2x. Okay, well, we can do that multiplication. 0.4, or I should be saying 4/10. 4/10 times 30. And that gives me 12. So 12 equals 2 times x. Now I want a single x. So to get rid of that 2, I'm going to divide both sides by 2. That leaves me with a single x here. So x equals 12 over 2, which is 6.